All right, so today we're looking at our notes on confidence intervals. So we've gone over both types of confidence intervals at this point, so I just want to make sure we've distinguished the difference between the two. There are a lot of similarities, however, there is some difference in their conditions. There is some difference in how you find it on your calculator. So though they are very similar in structure, we want to make sure that we're putting the right conditions with the right intervals and solving for the right things. So here's kind of a breakdown of their differences. So in our one prop Z interval, remember we're given a proportion or a percent in our word problem telling us this percent of people or this many people out of this many people chose something. So then our conditions are that they need to be a simple random sample, which is the same condition for this one. Our n times our p-value needs to be greater than or equal to 10, and n times 1 minus p needs to be greater than or equal to 10. And then our n value always needs to be a reasonable size. So we write that n is less than 0.1 of the entire population. So we're just looking that it's reasonable in size, that it's independent of anything else. So for our prop Z intervals, we run a one prop Z interval, which is letter A on most calculators. And then if we're trying to find the sample size, we use these two formulas depending on if we have an estimate, a point estimate or not. So those are our one prop Z intervals. Our T intervals is when we're given a mean in a standard deviation, or a set or a table of values, because we can also find it from a table of values or data. Our conditions, we also need it to be a simple random sample, so that one doesn't change. The only real difference in conditions, because this should still have number 3's condition to be the same as well, but the only difference in conditions is that your n value just needs to be greater than or equal to 30, and if it's not, then we need it to say that the population is normally distributed. So for this one, we run a Z interval, and then if we want to find its n value, we use this formula here. So those are kind of the key differences and how-tos and what we need. So now we'll go ahead and go over some examples together of each type. So number 1 on this page says the New York Times and CBS News conducted a nationwide poll of 1,048 randomly selected 13 to 17-year-olds. We can consider the sample to be a simple random sample. Of these 1,048 passengers, 66% had a television in their room. So because we have a 66%, this tells me that I'm doing a one prop Z interval already. So give a 95% confidence interval for the proportion of all people in this age group who had a TV in their room at the time of this poll. Interpret the meaning of the confidence interval. So we know we're running a one prop Z interval. So to do that, the things that we need, the values that we need a sample size, so n, and we talked to 1,048 people. And then we need an x value, which we don't have yet. However, we do have our proportion or our point estimate at 66%. So if I want to find my x value, I just take n times p. Because x is going to be important when we type this into our calculator. So if I take times 0.66, I get 691.68. And we'll keep that since it's a pretty rounded decimal. And then for my confidence interval, I'm looking at 95%. All right, so let's go ahead and check our 3 conditions that we have above. So first, is it a simple random sample? It says it is, so we're good there. Then we want to know, does n times p give us a number greater than or equal to 10? Well, we just multiplied n times p together, and we got 691, so that's definitely greater than or equal to 10. And then we have to check, is n times 1 minus p greater than or equal to 10? So if I do that, 48 times 1 minus 0.66, I get 356, 32, which is also greater than or equal to 10. And then our last condition is our N value less than 10% of our population? So if you think about, all I really think you need to do is add a 0 and ask yourself, is it reasonable to assume that there are more than 10,480 13 to 17-year-olds nationwide? And I would say, yes, there's definitely that many 13 to 17-year-olds. Okay, so now that we've checked all of our conditions, we'll go ahead and run our confidence interval. So to do that, we hit stat, go over to test, and then we're looking for our one prop Z interval, not Z test, our one prop Z interval. So that's letter A on our calculator. So then our X value we got was 691.68. Our N value was 1,048. And we want a 95% confidence interval. Oh, I forgot, your calculator does not like to run this test with decimals. So I actually need to just round this to 692. My apologies. So now I get that my confidence interval is 0.63163 to 0.68898. So then we can interpret this result interpret the meaning of this interval. So I'm going to say I am 95% confident that the interval 0.63163 to 0.68898 contains the true proportion of all people in this age group who have TVs in their room. And we're pretty consistent in our wording of this. I'm, however many a confidence interval we have, confident that the interval, whatever number to whatever, contains, and then we put it back in context to the problem that we're working on. We want to make sure that someone could read the interpretation of this and not necessarily need to have read the whole problem to know what we're talking about. Okay, so let's go ahead and look at our next example. So if you turn your paper over, we'll look at number 2. So it says we have an IQ test scores of 31 7th grade girls in a Midwest school district. We have calculated that the sample mean is 105.84 and the standard deviation is 14.27. So the fact that I'm given a mean and a standard deviation tells me that I'm running a T interval. And I want to give a 99% confidence interval for the average score in the population, assuming IQ scores are normally distributed. What is the margin of error? So, values that we'll need. Our N value is that we have 31 7th grade girls in our sample. Our mean is 105.84. Our standard deviation is 14.27. And I want a confidence interval of 99%, so 0.99. All right, so if I check my conditions, is this a simple random sample? It says that we don't have that it's a simple random sample, but we're going to assume it's one so that we can continue to keep going. Then we need to know that our N value is greater than or equal to 30, which it is in fact. And then we want to know, is our N value a good size? So if I add a 0 to this, is it reasonable to assume there are more than 310 7th graders in the Midwest school district? Yes, it is. So we are safe to run our confidence interval. So I'll go ahead and go over to my calculator. I hit stat, go over to test. Because I'm given a mean and a standard deviation, I'm running a t-interval. And then I want to make sure that I'm inputting stats. I don't have data in my list, so I'm just inputting the values that I have. So my mean is 105.84. My standard deviation is 14.27. My n value is 31. And I want to be 99% confident. And I messed that up, so 14.27, 31, 0.99. All right, so when I calculate this, 792 and 112.89. Okay, so when I interpret the meaning of this result, I can say I am 99% confident that the interval contains the true mean or the true average test score for 7th grade girls. So now, remember when we're talking about point estimates and margin of error, point estimates is the number in the middle. In our t-intervals, our mean is the middle value. So if I was to compute this, and I can just to make sure, but if I find the middle of these two numbers, so I'm going to add them up and divide by 2, it should be my mean, because that is 841, so it's a little off, but my mean is supposed to be the middle of my interval every time. Then the margin of error, so my point estimate is my mean, which is 105.84. My margin of error is just the distance from this middle point to one end of this graph. So one end of this interval. So I can either do 105 minus this or this minus that. I'll get the same value either way. So if I do 112.89 minus 105.84, I get 7.05. If I do 105.84 minus, and it might be a little off because I rounded that last time, but they're pretty close in number. So my margin of error is 7.05 because that mean, that point estimate, is my middle value. All right, I would suggest pausing the video and trying the next two on your own, just to make sure you can decipher the difference between the two intervals and write out all the details. But we'll go over them together after that. All right, so looking at number 3. Common claim is that garlic lowers cholesterol levels. In a test of effectiveness of garlic, 49 subjects were treated with a dose of raw garlic and their cholesterol levels were measured before and after the treatment. The changes in their levels have a mean of 0.4 and a standard deviation of 21. Construct a 95% confidence interval to estimate the mean net change in cholesterol after the garlic treatment. What does a confidence interval suggest about the effectiveness of garlic reducing cholesterol levels? So, because I'm given a mean and a standard deviation, I'm working with a t-interval. So then for t-intervals, I need my n value, which was 48 or 49 people. My mean is 0.4, and my standard deviation is 21. I'm looking to construct a 95% confidence interval. So those are all the kind of pieces from the word problem that we need. So now when I go to check my conditions, first I want to know if it's a simple random sample. We will assume it is, even if it doesn't say that it is. Because we're running a study, it's pretty widely assumed if you're going to run a study, you're going to run a simple random sample. Then I need my n value to be greater than or equal to 30, and 49 is. And then I need my n value to be less than 0.1 of n. So then if I do 490, it's reasonable to assume, right? If we're talking about looking at cholesterol levels, there's more than 490 people who have cholesterol levels that we could be testing. So we're safe to run our confidence interval. So to do that with our calculator, we'll hit stat, go over to test, down to t-interval. I'm using stats here because I know my mean is 0.4. Oops. My standard deviation is 21, and my n value 49, and I want a 95% confidence interval. So I get this as my confidence interval, which means I can say I am 95% confident that the interval So I'm 95% confident that the interval negative 5.32 to 6.4319 contains the true mean net change in LDL cholesterol after garlic treatment. So when it asks, what does this suggest about the effectiveness? Well, negative means that it had no effect. So considering that it's anywhere from -5 to +6 means that there's a good chance it's not really going to do anything, right? With 0 being kind of the middle of that. Or middle is 0.4, but 0 is close to the center of that. It means more than likely it's not really effective for everybody. It doesn't really quite have a good effectiveness rating. All right, so then our last example. Of the 148 teens surveyed, 198 named Fox as their favorite television network, given 90% confidence interval for the proportion of all people in this age group who would choose Fox as their favorite network. So we're given a proportion of people. So we're going to use our 1 prop z interval. We know our total amount of people surveyed was 1,048. Who responded yes, or who as part of our percent of yes in this would be 189. And then we want a 90% confidence interval. So if I want to find my point estimate or my proportion, I can do my x divided by n in this case. So 189 divided by 1,048 would give me 0.18 as my point estimate. We'll just need that for our conditions, so it's good to have now. So when we check, is it a simple random sample? We'll assume that it is. We want to know if n times p is greater than or equal to 10. Well, that's n times p is the same thing as x, but if I do 1048 times 0.18, I get 188, or about 189, which is definitely greater than or equal to 10. If I do n times 1 minus p, I have 1048 times 1 minus 0.18. I get 859, which is definitely greater than 10. And then if we look to see if our sample size is reasonable, it would be easy to assume that there is more than 10,000 teenagers, 10,480 teenagers that we could survey for this result. So our conditions are checked, which means we can run our confidence interval. So I'm going to go ahead with my calculator, hit stat, test. I'm running a 1 prop z interval. My x value is 189. My n value is 1,048. And I'm running a 90% confidence interval. So when I do that, I get 0.16081 and 0.19988. So from there, we can interpret this. Let me move my paper. I am 90% confident that the interval And again, we want to make sure that our interpretation has enough information that somebody wouldn't have to go back and read the whole problem to understand what we're talking about. So I'm 90% confident that the interval 0.16081 to 0.19988 contains the true proportion of teenagers who would choose Fox as their favorite network. And we've talked about this before, but our point estimate, right, is that value that's right in the center of this. So if we were to compute for our point estimate, it should match up with the same division that you did here with the decimals. So then if we wanted to find the margin of error, we would just subtract in this case. So hopefully that's a good review of our two types of confidence intervals that we're running for this unit.